What is best in life?
To crush your enemies, see them driven before you, and to hear the lamentation of their women.
That is good. That is...
Greetings once more and welcome back. In the last part we saw that FLATTARDS don't understand that objects further away have a smaller angular size, that their magic flying spotlight must change speed to maintain 24-hour days, whilst also magically moving at the same apparent rate across the sky every day, whilst also breaking the fundamental principle of the conservation of angular momentum. Naturally, a continued deluge of more basic geometry that kids can handle without adult supervision was too much for FLATTARDS, and not one attempted to actually address the material presented. They will, after all, deny the most basic and readily observable aspects of reality. We saw in Part 2 the complete train wreck of thought that led the finest FLATTARD minds to settle on the idea that the flying spotlight is always above the surface of their fantasy frisbee. In this part then we're going to continue doing the thinking for them, and we'll find out whether a magic, speed-changing, momentum-defying flying spotlight with a shape-shifting lampshade can rise and set over a Purdue prestidigitator's pancake. Let's go. We've previously seen that Earth has two celestial poles, the southern one of which FLATTARDS have no working explanation for, and that a portion of the sky will be circumpolar, and that portion is given by your latitude. Outside of the Arctic and Antarctic circles, everything in the celestial sky outside the circumpolar region for your latitude rises and sets every day. This of course includes the Sun and Moon. Satellites in low Earth orbit also rise and set, though the directions depend on their orbits. You can watch them with the naked eye if you don't have a lot of light pollution. Closer to Earth, no matter where you are, clouds and aircraft can appear from beyond the horizon and disappear beyond it too, as can boats and ships on large bodies of water. Objects attached to the Earth, be they structures such as oil rigs, buildings or mountains, can too, provided that you as the observer move instead. How do these things happen? The prime justification that FLATTARDS vomit between each other like the intellective equivalent of two girls, one cup is, but the law of perspective. However, they will not provide, when asked, any specific wording or mathematical model for what their law of perspective is, how it allegedly works, or how we can predict what any given scene should look like to an observer. Whilst it is true that lines parallel to the observer's line of sight will appear to converge at a single point at an infinite distance, FLATTARDS like to avoid the infinite distance part, particularly as their flying spotlight is, according to them, less than 5,000 kilometers above Earth. They also ignore the fact that any given scene can have multiple vanishing points, but let's just stick with one because we don't want to overload the poor fools. Here's Cletus the FLATTARD, looking into the distance on his flat Earth. Let's have his eyes a nice round 2 meters above the ground. He's looking straight ahead, so his line of sight runs parallel to the ground. We can all agree that his line of sight will be 2 meters above the ground forever, given that Cletus is stood on a flat surface. We stick a pole in the ground with 3 lights on it, a green light on the ground, a red light 2 meters high, and a blue one 4 meters high. Let's have a whole bunch of these poles stretching out into the distance. Imagine them carrying on forever past the right edge of your screen. Whichever pole Cletus looks at, and no matter how far away it is, the blue light will always appear above his line of sight, the red light will always appear on his line of sight, and the green one will always appear below his line of sight. Lines running through each set of lights run parallel to the flat Earth forever. We can see that from Cletus' view, as the lights stretch into the distance, the angle from his line of sight to the green and blue lights narrows. That is to say, as he looks into the distance, they appear to converge on the red lights. At what distance do the lines passing through all the lights converge? Well, those lines are parallel, so they never do. From Cletus' view, the imaginary point at which the lines appear to converge, infinitely far away, is the vanishing point. In this example, it is 2 meters above the ground. For the benefit of flattards, it is worth stressing: parallel lines never meet. The vanishing point is an abstract concept. It is infinitely far away. If the Earth were an infinite plane, Cletus would see its surface stretching out into the distance toward the vanishing point, but the surface would never quite appear to reach it. Cletus will always have to look down from his original horizontal line of sight to look at something on the ground, no matter how far away it is. Similarly, if Cletus were in a corridor that went on forever, he would always have to look up from his original line of sight to see a point on the ceiling, no matter how far away it is. What's true for ceilings and lights on poles is true for anything else above your observation height, be it clouds, mountain tops, tops of buildings, aircraft, and if we really lived on a giant space pizza, every object in the sky, including the sun.
Hey!
This, of course, means that the sun can't set if it's flying around above a flat Earth. It's so simple, even a child can get it. Flattards? Not so much. Since everything in the sky does rise and set every day, it's obvious not only that flattards don't understand perspective and vanishing points at even a rudimentary level, but that perspective itself shows that their delusion of living on a giant pancake is bollocks. Flattards think just saying the word perspective solves all of their problems, even though we've just seen that their understanding of it is below that expected of someone graduating from using wax crayons as their writing implement of choice. In order for the sun to rise and set, you need a horizon. And you'll be unsurprised to hear that that's another thing that flattards can't wrap their heads around. The flattard version of perspective has to work like this. Instead of being able to see the ground stretching off into the distance for many thousands of kilometers, it forms a horizon at a much shorter distance. Our lights on poles stretch out to the mystery short-range horizon, and then equally mysteriously start disappearing below it, from the bottom of the poles up, until we can't see the lights anymore. This happens for everything on and above ground, including the sun, moon and stars. But hang on, we've already seen that the very simple geometry behind perspective just doesn't work this way. Lines parallel to the surface of Flattardia would run parallel to that surface forever. How can the surface of Flattardia even form a horizon, and how can objects be obscured by it? How could the red lights on Cletus' line of sight ever drop below his line of sight? How could anything above his line of sight ever be below it, or set below the horizon? These are all very good questions, which explains why they haven't been asked by flattards. Flattards clearly haven't thought this through, to nobody's surprise, but this can only mean one or both of two things for them. Either straight lines aren't straight, in which case this must also apply to the surface of Flattardia itself, in order for a short-range horizon to even form. In other words, their flat Earth isn't flat, by their own standards. Or parallel lines aren't parallel, because reasons. Regardless of whatever ad hoc bullshit flattards want to cook up this time to excuse themselves from having to actually think about their own stupidity, they're now in the position of having to claim that basic axioms of Euclidean geometry are magically false, whilst also claiming that Earth is flat and subject to Euclidean geometry. Which basically means that flattards are insane. Consider our flattard in a really long corridor again. According to flattard perspective, beyond a few miles he should no longer be able to see the floor of the corridor, and he should see more distant lights on the ceiling disappear below the horizon on the floor. Well, we've already established that this makes no geometric sense whatsoever, so let's reset the corridor. What if we hung our flattard by his feet from the ceiling, put some lights on the floor, and rotated the camera so that it only appeared that our flattard was stood on the floor? What would flattard perspective do here? Where would the horizon be? On the floor? On the ceiling? What if we strapped our flattard to a support on the wall, and rotated the camera 90 degrees, where would the horizon be now? On the floor? On the ceiling? On the wall? Which one? As we can see, the concept of a horizon with things disappearing behind it makes no sense in an environment comprised of flat surfaces. Yet FLATTARDS claim that we do live on a flat surface, and that things are obscured by a horizon breaking the simple geometric principles we've seen. You see, the undocumented, unmodelled and utterly useless FLATTARD version of perspective has a preferred direction. This is odd, because lines of sight and perspective in reality work in any orientation. For example, if you were on the ground between some exceedingly tall buildings looking up, there is no distance at which one set of buildings would get a horizon, and the other will start being obscured by the horizon. If we were to take our lights on poles example from before, and set it on an enormously long ramp, which we could set at any angle, and have Cletus looking along the ramp, there is no distance at which the ramp would form a horizon behind which more distant poles and lights would start disappearing bottom first. And yet, FLATTARDS expect you to believe that if we return the ramp to align with the ground of their fantasy frittata, you'll get a horizon a short distance away, mere kilometres, behind which objects will increasingly be obscured as they become more distant. Reality simply doesn't care what direction you're looking in. The FLATTARD version of perspective, which they're incapable of putting into words or mathematics, is quite simply bullshit. And like all ad hoc explanations they concoct in an attempt to sound like they know anything about anything, when their explanations can't even stand the most basic scrutiny, it's just another indicator that the idea of Earth being flat and having its own direction-specific version of perspective is bollocks. Let's hammer this FLATTARD perspective, or flirspective, crap home. If the Earth were a giant rock omelette 40,000 kilometres across, we would see the edge of the world somewhere far in the distance, very slightly below the observer's vanishing point, if there were no atmosphere, for the simple geometric reason we saw earlier. However, there is an atmosphere, and so both normal people and FLATTARDS can agree that we can't see land many thousands of kilometres away. So, depending on dust and humidity levels, scattering of light is going to limit how far we can see looking through the atmosphere near ground level. Fine. How far though? Well, FLATTARDS say the Sun is 3,000 miles or 4,800 kilometres high, but as we saw in the last part, at sunrise and sunset, the Sun is going to be much further than that from an observer. We looked at an example of an equatorial FLATTARD observing at an equinox. The setting sun is nearly 15,000 kilometres away from him. This presents a paradox for our feckless FLATTARD observer. With a nice clear sunset giving an unobstructed view of the Sun, he can see 15,000 kilometres, or more in other parts of the pancake world, to the Sun. But he can't see all the land stretching out as far as the FLATTARD flying spotlight. FLATTARD excuse makers will be saying the land undulates, so using land is not fair. Okay, well, they also parrot, like the mindless imbeciles that they are, the phrase that water finds its level. So let's use the sea. Cletus can see 15,000 kilometres or more to the Sun, but he can't see all the sea stretching out as far as the FLATTARD flying spotlight either. Stood a couple of metres above the sea, the horizon is a mere 5 kilometres away, and on a really clear day it's as crisp as you like, clearly showing that you can only see the surface of the sea to a short distance, and that's it. Well, why can't you see the sea beyond that when conditions are so clear? Think back to our earlier discussion. You should be able to. So here's what FLATTARDS think reality must look like. Cletus is looking out over the sea at the equator on an equinox. His line of sight is 2 metres above water. The Sun is 15,000 kilometres away and appears down here because fuck geometry and perspective. Cletus can see the Sun setting. However, when he looks at the sea, he can only see as far as 5 kilometres, because fuck geometry and perspective. Why can't he see thousands of kilometers of sea or land beyond that? Why can't he see them even though there's clearly nothing in the way? Because reasons, and because fuck geometry and perspective. The only possible Flattard explanations for this involve cocking up geometry as we saw earlier, or invoking strange new properties of light that nobody's ever heard of, nobody has measured, and nobody has observed. Maybe light from the surface of the sea or land more than 5 kilometers away just gives up. It just stops trying to reach your eyes. You can't see any sea beyond that, because reasons. The sky, however, isn't subject to this restriction, and so light from the sky and from the sun thousands of times further away is clearly visible. The light from other objects more than 5 kilometers away also aren't subject to any magical distance restriction either. Distant ships, structures, buildings, mountains are all visible and appear obscured by the horizon, because fuck geometry, fuck perspective, and fuck consistency in the Flattard world. In reality, the distance to the horizon depends on the observer's altitude, which also knackers the lazy light idea, because as any fool knows, when you're higher you can see further. So if we put Cletus on a 100-metre high hill, he'll now find that photons that couldn't be asked travelling more than 5 kilometres before now can be asked to travel more than that just because Cletus changed his height. In fact, they'll travel 7 times further, and Cletus' horizon will now be 35 kilometres away. He'll also be able to see more of those partially obscured ships, structures, buildings and mountains, and if he's really quick getting up the hill, he can even watch the sun set again. Coincidentally, the distance to the horizon on a clear day is exactly what you'd expect at a given height above the surface of a spheroid around 12,700 kilometres across, which is the size of the Earth. We can easily cross-check reality against some more basic trig that Flattards just can't deal with. Here's a circle representing a planet with radius r. Here's an observer whose eyes are at a height h. As our observer looks to the horizon, a distance d away, his line of sight will form a tangent to the surface, so that line will be at 90 degrees to another radius line. Oh look, we've just made a right-angled triangle. Well, virtually everyone who isn't a Flattard understands Pythagoras' theorem, and since Flattards have yet to explain why the basic properties of triangles are part of a worldwide conspiracy against unemployable lunatics, I think we can trust it. So, r squared plus d squared is going to be equal to r plus h squared. Let's expand that, so we get r squared plus 2rh plus h squared. The r squared on both sides cancel out. Keep on crunching and we find that the distance to the horizon, d, is the root of h 2r plus h. If our planet were Earth, Earth isn't a perfect sphere, it's slightly oblate, so let's plug in the mean radius, or 6,371 kilometres, and we get a simple formula to approximate the distance to the horizon for an observer at a given height h on Earth. Plug in an observer height of 2 metres and we find that the distance to the horizon is 5.05 kilometres. Well, no disagreement with reality. Plug in an observer height of 100 metres and we get a distance of 35.7 kilometres. Again, no disagreement with reality. And you can do this for any height you like. It's worth noting at this point that Flattards have no way of working out the distance to the horizon for an observer at a given height, based on the idiotic notion of living on a giant Jaffa cake. They also have no explanation for why the horizon on a giant space pizza made by an invisible wizard could even be at such short ranges when, as we've seen, any observer would always be looking down onto the flat surface they think they live on. No alarm bells ring inside the pus-filled crania of Flattards, so they just cling doggedly to the belief that the inability of their bullshit to explain anything is still proof of their bullshit. Flattardia does not make a lick of sense to anyone of sound mind, so we find ourselves uncompromisingly drawn to the conclusion that the idea that we live on a pan-dimensional prestidigitator's magic pancake is complete bollocks. In the next part, we'll continue looking at more ways that a horizon can knacker flat Earth dogma. See you then.
Sei sotto un cielo sbagliato.